Welcome to SCARLETT. SCARLETT, which stands for Scalable and Reconfigurable Electronics Platforms and Tools, is an EC-funded FP7 First Call project coordinated by Thales Avionics. This presentation will provide you with a general overview of processes and tools for Next Generation IMA. IMA second generation will provide the system designers with more options in terms of computing power and communication means. The number as well as the criticality of integrated systems in the aircraft will increase. From technology and process point of view, it follows that IMA integration becomes more complex. One SCARLETT objective is to provide optimized processes and tools for the use of next generation IMA technology in future aircraft programs. Why are new processes required? Two main reasons have been identified. Firstly, technical innovations in the IMA technology impact processes and tool chain. These are new equipment types, PF functionality, additional tools, and methodology. Secondly, airframers in Europe have demonstrated successfully the feasibility of the development of the new architecture and integration process. However, IMA introduces considerable additional effort for system designers as well as for IMA designers. Additionally, the current process does not result in an optimized aircraft architecture. The existing process shall be optimized so that the required resources and development time is minimized and the design maturity is maximized. In previous aircraft programs, the design maturity level required by the customers at TIS was not fully achieved. The full maturity of the aircraft platform was completed after the original due date. Consequently, airframers have had to spend additional time and budget to achieve the required maturity level. In future programs, the goals will be to reach a respective EIS maturity earlier in the program and improve the overall design maturity level of the system architecture. This is achieved by optimized validation, evaluation and verification activities on platform level. Thereby, the basic integration philosophy does not change. Airframers will still follow the tried and tested methodology of incremental certification. Each system hosted on the IMA platform can be qualified individually. Three main tasks have been identified that will help to achieve the objectives. Firstly, introduction of new tools. With the introduction of IMA, the system designers have been faced with more complex technology and processes. System design cannot be seen as standalone anymore, but requires harmonization with the new platform architecture approach. The governance and control of the design steps are supported by introduction of new tools. Secondly, development of a seamless tool chain. The airframers follow the waterfall process defined in the V model. This process shall be supported by a seamless tool chain where the output of one tool can be used directly as an input of the following tool, without manual interaction. The design process will move towards a paperless workflow where design data remains in electronic format. Paperwork shall be generated only for validation and qualification activities. Thirdly, standardization. A standardized configuration format is a means to harmonize and ease the platform configuration. For example, if each equipment type used in the platform requires its own configuration format, then there will be multiple configuration processes and therefore the complexity of the complete platform configuration will become unmanageable. Introduce new platform design tools. This slide lists a subset of tools developed in the SCARLETT R&T program. The Early Validation Tool, EVT, helps the platform designer to allocate platform resources for system functions. Architecture evaluation is supported by automatic application of respective criteria and constraints. the output of EVT is an optimized architecture. The multi-equipment simulation tool provides a simulation environment that allows several respective applications to run in parallel. The validation of system functions that are distributed on several equipments is therefore eased. The Smart Configuration Databases eases time-consuming system and equipment configuration work. Checks during the configuration definition reduce development and test efforts. Clearly defined responsibilities for the configuration work share between partners will enable lean design processes. The platform framework provides the backbone for the development of seamless toolchain. SCARLETT applies the SOA technology and uses the Eclipse framework as a basis to provide a common HMI. The early validation tool. The old process is based on local system optimization processes. In previous aircraft programs, the complete definition of the system architecture and its optimization was performed at system level only. Each system integrates its optimized architecture into the aircraft. The sum of the optimized system architectures did not automatically lead to an optimized aircraft architecture. The new process is based on the inter-system optimization process. In future, architecture optimization shall be performed at platform level. Firstly, the system requirements are collected from all integrated systems. Based on the set of requirements, the architecture design process is started. The design process has now moved from a local system to a centralized optimization process. The central design on platform level reduces the number of incompatibilities between the systems. Due to the large amount of configuration data, the design process requires tool support. The early validation tool is able to manage architecture optimization and apply respective constraints and criteria automatically. Multi-equipment simulation tool. The systems are widely distributed on IMA second generation more than on previous aircraft architectures. Widely means the distribution of the system functions incorporates the integration of more controllers than in conventional architectures. For example, the Ventilation Control System, VCS, is distributed on 27 different equipments today. In previous architectures, the VCS has been integrated within 4 core processing modules, although many other specific VCS system equipment were also used. Thus, the development, validation, and verification of configurations and applications becomes more complex. The multi-equipment simulator eases application development because the functional interplay between different applications may be tested before any hardware is available. Optionally, the multi-equipment simulation may be used as stimuli for application verification on airframers' test rigs. The configuration front-end, CFE. The introduction of CFE has the following advantages. Configuration checks are already performed during the configuration activities. In previous programs, configuration checks were performed during tests. Managed configuration responsibilities. A set of roles defines the respective equipment parameters a person can modify. Thus, a module supplier is only able to edit parameters for module suppliers, and a system supplier is only able to edit system supplier parameters, etc. The documentation of critical software development requires much paperwork. Documents are produced by an automatic report generation function. The configurations of different equipment types are managed by one tool only. An example of configuration definition is shown on the right side of the slide. The configuration part A is inserted into the configuration front end. After the usage domain check, report A is generated automatically. Configuration Part B is added to the configuration. Compatibility between Part B and Part A is checked by the tool. After the usage domain check, report B is generated automatically. Configuration Part C is added to the configuration. Compatibility between Part C, Part A and Part B is checked. After usage domain check, report C is generated automatically. All parts for the configuration are generated. The load can be produced by the SDEE kit. The CFE is introduced to support the intelligent configuration, definition and management process. It increases maturity and reduces development time. Tool framework. A tool framework integrates various tools used in the development and test of the respective platform. Tools linked to this framework use the same HMI and may communicate to other tools on the platform. The tool framework supports the step from a paper-based to an electronic database design process. The engineering data between different design steps remains in the electronic data format. This saves time due to the reduction of document production. The design maturity level increases because manual interference is reduced. There are two main competing solutions, which are the engineering backbone and service-oriented architecture (SOA). SCARLETT applies SOA concept and uses the Eclipse platform. A tool framework increases the efficiency of the whole tool chain. Through improved engineering data exchange, it can accelerate the design process and increase the maturity. Introduce a tool chain that supports seamless integration between design steps. The IMA platform development and system integration is performed in 6 main steps. Each step requires one or more specific tools. The top-level requirements at aircraft level are still defined in a text document. The function modeling step, textual requirements are interpreted into system functions. Several modeling languages are available for function modeling. For example, SysML and MATLAB are widely used. Additionally, SCADE is used for critical functions. In the PF evaluation step, the modeled functions are mapped on hardware. Architectures are identified and their compliance to predefined criteria is evaluated. There are different compliance criteria that may be evaluated by different tools. In SCARLETT, a network and architecture evaluation tool has been developed. In the PF configuration step, the selected architecture of the previous step is completed by equipment-specific configuration data. A standardized configuration format simplifies the configuration of equipment from different module suppliers. In the frame of SCARLETT, a standard configuration format and the supporting CFE tool have been developed. The output of the PF configuration is used as an input for the platform simulation tools. Based on a given configuration, the application coding can be finalized. In SCARLETT, the platform simulation tool, PFS, has been developed. With the PFS, applications can be validated without the availability of real equipment hardware. Applications with the respective configurations are verified in the PF verification step. An extra verification step is required when respective simulations are not fully representative for certification issues. Different tools for automated configuration tests and functional verification have been developed in the frame of SCARLETT. The results of the PF verification step are verified loads that are ready to be loaded on the aircraft equipment. A seamless tool chain helps to accelerate the design process and increase the maturity of the applications and configuration tables. Standardized data exchange formats and tool interfaces. There are several areas of standardization. Amongst others, SCARLETT investigates the use of standardized configuration table format. The IMA platform can rely on equipment from various suppliers. Today, each equipment type has its own configuration format. Each configuration format requires different processes to fill the configuration files. Additionally, each configuration format requires new or adapted tools on airframer side. After completion of the configuration, the module load is produced by module-specific supplier tool chains. Each equipment type will use its own tools to produce a load. In future, both the module types and the module-specific supplier tool chains remain module supplier's responsibility. Standardized configurations allow the reuse of processes and tool chains for different equipment types and aircraft programs. Conclusion: a standard configuration format allows the reuse of processes and tools. It saves time and money for both airframers and module suppliers. The introduction of new tools, as well as the optimization of processes, will help to improve the design maturity and finalize the design in time. A quantification of the process improvement is possible but difficult. Project as well as product-specific parameters must be evaluated. Project-specific criteria are time, budget and resources savings, and product maturity specific criteria has parameters like reliability, availability, weight, etc. In previous aircraft programs, the process has been mainly linked to system development. Future processes must consider much more the aspect of platform design processes and their dedicated tools. Thank you for listening. Please visit our website, and should you have any further questions regarding this presentation, please do not hesitate to contact any of the persons mentioned. Thank you for your attention.